Brilliant. So, for our next talk, we are going to be having security experts Brian Demers and Matt Raible joining us from Okta, a authority in the security conscious space of cloud native software for sure. They are going to be bringing us some considerations about auth security, both authentication and authorization, about security patterns for applications, APIs, and infrastructure. So lean in, join us with Brian and Matt as they tell us how to lock that shit down.
Hello, developers. Today, we'd like to tell you about how to lock your shit down using auth security patterns. Who are we?
Hey, Matt. I'm Brian Demers. I write a lot of Java code, and in my free time, I even do a little snowboarding. I know you're a skier, but I won't hold that up against you either.
And my name is Matt Raible. I consider myself an open source developer more than anything. And Brian, aren't you a beekeeper as well?
I am. I started beekeeping a couple of years ago, and we're getting close to the big fall harvest. So hopefully things work out. Last year did not go so well for me, so I'm crossing my fingers for this year.
Nice. And fun fact.
Yeah, I was going to say I don't see a picture of your bus here. What's going on?
No, the bus is doing well. In fact, I finally got the garage I've always wanted at our house. We actually have we have 3 garages at the ranch, and for the longest time, my wife had the good garage. And because she got a Tesla and the battery was mounted in a different garage, I finally got the good one. So Hefe's doing well. And one thing I did want to mention that people might not know about Brian, fun fact, is he actually created the Maven wrapper. Is that true? That's true, right? Like you wrote the prototype?
Yeah, so I created the initial wrapper. So I'm a Maven committer, so my original plan was to sort of push that back to the Maven project, but life happened and things didn't work out, so it got picked up. I created the original project. It got picked up by I forget what they're called now, Takari, some other folks, Jason Van Ziel, some other folks from the Maven world, and then it eventually found its way back to the Maven project, which was my original intent all along. So I'm very happy about that.
Nice. So today's agenda, wrong button. We're going to talk about a whole slew of things, right? We're going to start off by just defining what auth is, and then we'll have a section on app auth. And you'll notice that we're putting auth in all these titles. So in some senses, things might not relate to authentication or authorization. So that's why, we've tried to clarify that. And then infrastructure, and then we'll give you some action items at the end. So Brian, what is auth?
That's a great question. So depending on who you talk to, it sort of means different things, right? But as sort of Matt hinted at, normally we talk about authentication, right? Which is the who, that's the proving my identity. And then there's kind of the what, like what I have access to, which is the authorization, again, validation of access, right? So maybe a simple example, I go over to Matt's house. Matt's in Colorado. I'm in New Hampshire, but it's a long walk. But so I go over to his house and I knock on his door, and he looks through a peephole or a window or however you look at people through your door, and he identifies me, right? So he's authorizing me as he opens the door. I come in, and maybe he authenticated me, right? Because he let me in, and maybe he's authorizing me to sit on his couch and we hang out or whatever. But maybe I'm not authorized to go open his fridge or go through his cupboards and get some snacks. I don't know. Maybe I will be. Who knows? But but we're really talking about more than that, right? So it's more than just those two pieces, right? It's the overall security of your application, right? So if Matt leaves his window open and I climb through somehow, and I've skipped all of that process, right? So we need to be aware. Matt needs to lock his windows down. So just like your applications, you need to be aware of all these things. So we're going to cover some front end concerns and go all the way to the back end infrastructure.
Thank you. And why should we care?
You want to build more secure apps, right? I hope.
Oh, of course you do, right? I mean,
right. Yeah, so Matt and I have been doing this for I don't know, like almost 20 years, or a little, give or take, I think.
Yeah.
Many of those, yeah, right. Young me would call us dinosaurs at this point, but I thought I was had to be destined for management, which I'm very glad that was not the case. But many of those years have been in and around the security space. We've been at Okta for, I think, I don't know, almost 5 years or so, and we like to think we know what we're talking about. They haven't fired us yet, right? So we have that going for us. But, so when I started, and I'm guessing the same is true for you, Matt. If you were building an app and you needed some sort of auth, you would just stick passwords in a database, call it a day, right? Maybe, hopefully, you hash them or something. But kind of fast forward today, looking back on things the way we've done things, we know we did a terrible job at those, like as an industry.
And that's a great segue into a brief history of authentication and just auth in general, because this is something that Brian researched and I was fascinated by. The first password was actually invented in the 1960s, and it was MIT's compatible time sharing system. And because people actually had multiple users on the system, they decided to use passwords to lock down the files for each of the individual users. The funny thing is, it was hacked in 1962 by one of the people that actually worked on it. And someone was able to print out all the passwords in 1966 as a way of getting more time on the computer, because all the researchers were limited in how much time they could spend. So they found if they just used other people's passwords, then they could get more time. So I'm sure you're all familiar with doing that with Netflix, maybe, or something like that, right? Sharing the old passwords. And it wasn't even until the 1970s that hash passwords came along.
Hey, Matt.
And then, yeah.
You probably have some like little bubbles on the screen you can advance to too, right?
Oh yeah, look at that. Animations, right? And then 70s was hash passwords with RSA, and that was 1977 by Raible, Shamir, and Adelman, and it's an algorithm for public key cryptography, right? So it was the first time, and we've had cryptography around since the ancient ages, like kings and queens and stuff used to use them, right? And when they did that, there was always an exchange of information before they actually, cryptographically signed a message, right? Saying that, the fifth letter would be used or the sixth letter. And so they had keys and different ways of doing it. Well, RSA was the first time that there was public and private keys, and the public key could be used to, decrypt a message. And so that was pretty revolutionary in the sense of, it's the first time people didn't actually have to talk to each other beforehand. And then, we got into SSL in 1994, thanks to Netscape. There was version 2 in 95 and version 3 in 96. So that kind of implies there might have been some issues in each of the implementation. And then it was all deprecated. I think SSL stuck around for a bit, but TLS in 1999 is kind of where we're at today. That's transport layer security. And then federated identity came along. Brian talks about, when we were all doing passwords, and I certainly remember that in the late 90s and early 2000s. I probably didn't even know to, encrypt my passwords until a CG security came along in 2003 or 4. And so, SAML came along in 2006, and people use that for federated identity. You might notice that other things came along around that period, SOAP, for instance. So that's just to put some dating on how old SAML is. And then OAuth came about because SAML was good for web browsers, but it wasn't great for devices, right? And TVs and phones. And so OAuth was invented in 2012. That was the first RFC was 2010 for OAuth 1. 2012 was OAuth 2. And then 2014, they realized they needed to add some identity to that. So that was OpenID Connect, or OIDC. And then what people realized is, we were kind of doing it wrong on mobile devices, where we were storing client secrets, and engineers reverse engineered Twitter's app and got the client secret that they were using for their app and were able to post on anyone's timeline. And so they added PXE, proof key for code exchange, to make a authorization code flow in those devices. And so it's constantly evolving, right? And this is just up to today. It could change tomorrow, and there could be more specs and cooler things going on. So Brian, tell us a bit about the different types of people.
Yeah, so I think it helps to put things a little into perspective, right? Like I usually wear sort of the API developer hat. I avoid building front ends like the plague. I know you, Matt. You like to dabble a little more on the front end, but I can't make anything pretty. So, but yeah. So as we go through here, it helps, I think, to sort of put things in buckets, right? We know a lot of people wear multiple hats and fill multiple roles, and that's awesome. But you need to sort of be aware of some of the limitations of sort of each sort of group, right? And just think about secrets for a second, right? So as Matt just mentioned, we know that front ends and mobile apps, you can't really keep a secret, right? Backends also have some issues with secrets, right? We can keep them secret, but we still need to be cautious. We need to make sure we don't leak them, maybe in a log file or whatever, right? Keep them in memory or who knows what, right? And then DevOps, right? You have to manage those secrets. How do you get your secrets, into your application? And then maybe the security folks are just paranoid, right? They're kind of like, what do you mean everyone has access to those secrets? They want to lock that shit down.
That's a great point.
Yeah, as we go through, we're going to talk about some solutions along the way.
All right. So first of all, we'd like to point that we're talking about Auth, right? So I mentioned that earlier. And there's overarching security patterns that you should be worried about that aren't really so much about Auth. For instance, HTTPS. Always use HTTPS, right? We're not even going to discuss that because you should be using that throughout. Scan your dependencies for vulnerabilities. Like that's a no-brainer. Just do it, enable it, buy a service like JFrog's X-Ray or Sneak, or just use Dependabot, and keep your OSS frameworks updated. So, one of the things that we encounter with a lot of enterprise customers is they want to know how to do things with Spring's XML. And we're just like, oh, really? Like, come on, can't use Java config? And have you tried Spring Boot? So, try to convince, your managers and your cohorts that, it's important to keep things up to date. And then most importantly is all these patterns, really apply to the app developer. That's a mobile developer, maybe a SPA developer, and web. And I think it does, lend itself to talking about the different types of apps because they're very different and their security posture is different. So when we talk about web, I'm talking about web apps, and this is the traditional web app that you might have developed with struts back in the day, or Spring MVC or Ruby on Rails, where there's very limited JavaScript, right? There's maybe jQuery or something like that, but you're not using a full-fledged JavaScript framework. And then you have SPAs, which are single-page apps, and those are built with React or Angular or Vue, and those have, everything's on the front end, even the routing. And even if you're using like server-side rendering, which I find it funny that we've come back around to that in JavaScript, it still hydrates the whole single page app, and it's not pulling the HTML from the backend. And yes, there's certain frameworks that do that and they pull the HTML from the backend, but traditionally, SPAs are SPAs and they can live on a phone, right? And they don't have to actually, be on a server. And then mobile apps, which are very different themselves because they're native and, they might be able to embed a browser, which is like an anti-pattern, especially for Auth. And so it's good to define all of those. And, mobile apps are typically deployed to phones and tablets, but maybe they're even on TVs. I mean, you think, you want to go back to what it's like to work on Netscape 4, like try developing for a TV because those things have, limited RAM and abilities.
I'm chuckling. Like I one of my pet peeves is sort of typing in passwords on a television, like with the remote, right? Like you literally have to move over, and it's just yeah. There's solutions to that. Stop doing that. Anyway, so related to logging in, so basic auth, right? So this is built into a browser, and when I started developing, this was actually more commonplace. And we still see this a lot in some sort of backend services. I think Spring Cloud Config sort of uses basic auth by default, but you don't want to expose these things to your end users. It's great that it's built into the browser. I don't have to write any HTML for this. That's awesome. But it caches my credentials in the browser, right? It's often my credentials are going over the wire every request. So there's more chance for those to leak. There's no real way to log out. I would have to close my browser and hope my browser forgets them, but there's no also new patterns. So there's no MFA, right? So if you want to use Google Authenticator or YubiKey or what have you, you can't do it. So it's also pretty easy to do wrong. Matt sort of mentioned, TLS, right? nothing about this enforces TLS. So you could just send your username and password, over the wire. They're encoded, but they're not encrypted. So, if you're using basic auth, be careful. Right. And the other big thing is this also means your applications are handling user passwords, right? Which we know now is a problem. So Matt, what do you think of that? Ah, right.
And part of the reason is because, I have this shirt that we had made recently that says, I fight for the users. And I think, as like security professionals, right, we really want to not, spread fear, uncertainty, and doubt. But at the same time, like, we want to make it so your users aren't, chances of getting their stuff hacked. And so, we try to balance like developer ease of use and, protecting users. So after basic authentication was popular for a couple of years in the late 90s, clients started to say, to me at least on my projects, that, hey, can you make that form look like the rest of the app? And so along came form-based authentication. And this was very popular in Java EE in the beginning, and a lot of people used it. And still, the problem is you're still actually saving, users in your actual, database, chances are. And, what I've seen is even embedded auth, right? All these SaaS companies now that do identity have widgets that you can embed in your app or maybe even in your mobile app. And truth be told, what happens with a lot of that is that app can access those credentials. Now, whether it does it or not is a whole different ballgame, but it does have access to those credentials. So as far as trying to protect your users or fight for the users, that's not a great thing. And have you noticed two of the most popular sign-in providers in the world don't have widgets that you can embed? That's Facebook and Google. So when people say I don't want to redirect to another site to log in, you're but you'll do sign in with Google? What's the difference? So keep that in mind. And I have a good quote from our friend Keith Casey, login pages don't earn raises. So if you're hosting form-based authentication, it's highly likely the hosting app can access those credentials. So that's bad for your users. And then let's talk about, we're talking about the timeline here. We started with basic, late 90s. We got into form-based, and then we got into SAML in the mid 2000s. What do you think of that, Brian?
Yeah, so I kind of feel like I should apologize because I was writing a lot of Java code in the early aughts too, but we put XML in everything we could, everything, right? And SAML was one of those examples. It turns out it wasn't always a good idea. SAML is complex. There's a lot of surface area. A lot of that is actually because of XML. You can define attributes different. You can set up namespaces. Anyway, so there's a lot of surface area, which means we know now as developers, right? The more surface area you have, it's very likely the more vulnerabilities you have, right? So there's been a whole host of issues with SAML over the years. And I worked at Okta for almost 5 years, and I still have yet to have to build anything with SAML. There are better solutions. Matt mentioned this before, but OAuth 2 and OIDC have sort of filled all of those use cases. I think one of the biggest reasons that we hear people want to use SAML is because we've always done it that way. And I'm definitely, my response is always, that we've always done it that way is not an argument for secure code, So I would say, Matt, maybe stick another X on this one.
Boom. I agree with you there. I always tell people to try to not use SAML, and if your SaaS software actually supports it, maybe tell them to get with the program. Another one that's super popular in Java world, I think it's even more popular in Node and other languages, is JWTs. Stands for JSON Web Token, or JOT. JOT is actually the abbreviation, or the abbreviated name for that. You can look it up. It's in the spec. Instead of GWT, right, where they said it's GWT, it's actually written in the spec. So good on them for putting the abbreviated term in there. And a JWT string just has a header, body, and a signature that's separated by dots, and it's defined by an RFC, good old 7519. And it's had so many issues that a new RFC 8725 was created in February 2020 to list best practices, and it lists 9 different threats and vulnerabilities in that spec. So JWT is often used as a replacement for sessions, right, to make an app stateless. And it's not a terrible idea. I don't know if you saw, I was in a talk yesterday on Spring Security 5.5, and they showed how basic authentication, was used to protect an API, and it was using bcrypt for the passwords. And then I think as the demo of, JWT authentication as a resource server happened, then I think the feed cut out, so we never saw that. But, if you're doing basic authentication, it's going to be much slower than JWT. So that's why people, switch to JWT a lot. But what happens inevitably is people like to stuff a lot of information in the JWT and use it as a replacement for session tokens, and that's just a terrible idea. Session tokens have been around for 20 years. Your favorite framework probably supports it, and it works great. And if you need to scale, if you're worried about scaling that session, well, you got like Spring Session and Redis that'll do just fine for scaling that. So, and JWT isn't really auth, right? It's just a format for transferring data. So, it's one of those that I'm kind of like, meh. It's too often used as a buzzword, and people want to use it. And OAuth doesn't even mandate it for access tokens. And in fact, a JWT can be an opaque token. An opaque token is just a random string of characters. And guess what? A JWT can be that if you don't decode it. So, you can use it that way and go back to the, auth server and validate it. But really, they're not as great as people say they are. And I've got a couple, reference for that. So if you download these slides, we've actually already uploaded these on SpeakerDeck, and we'll throw a link into the Slack after this. But basically, one of my colleagues wrote this, actually former colleague, Randall Deggs, why JWT suck as session tokens. And he talks a lot about people are saving, bandwidth on generating or not talking to the user table, but really, you're generating a JWT, which, takes a lot of resources as well. And then this, what do we do about JWT, is an excellent podcast that I just listened to last week. And it talks about different ways of doing, authentication with APIs. And they talk about just, creating a token, for instance, and talking to it that way. Brian will get that in that section. And then they also recommended protobuf tokens after all other API tokens, or over all other API tokens. And we'll mention that when we get there as well. But I just recommend both of these from smarter people than me about why JWTs aren't as great as some people think they are. So check those out. And then we don't really have an X, right? We just have a meh. And then Brian, you want to take the next one here?
Sure. So Matt and I, we actually spent a lot of time talking about OAuth and OIDC, right? So the TLDR is that OAuth is an authorization framework. Again, that's kind of the what I have access to. And then the OIDC portion on top of that is the authentication. Again, that's the identity. But so everybody's actually used this flow, right? So Google uses this flow, GitHub uses OAuth, but even to get into Spring One, you used OIDC, right? So you went to the Spring One site, click some sign-in button. The site looks a little different today than it did 2 days ago. So sorry for my out-of-date screenshots. But you were redirected to the identity provider, right? And it was actually Okta. But you type in your username, your credentials. You hit that sign in, that blue sign in button, and that your data only went to Okta, right? So, or the identity provider, and this works the same way with Google and everybody else too. So they're the only ones that ever see your password, right? They validate it. And then flow returns to the application. In this case, it was Spring One. And then they make a REST-like request through a back channel, right? So that's basically your backend Java app or what have you. And it makes a request to make sure everything went fine in the front end. So that's how it verifies you're actually logging in. The best part of this, right, is the Spring One app never had to touch my password. And you get other things for free. You get like things like SSO and all those other things for free. If I add MFA or something to my application, the Spring One app doesn't have to change at all. It just works the same way as it did yesterday, but now I have more security when I log in.
I like that you mentioned MFA because, that's the next pattern that we have. I'd also like to mention that as far as the authentication that happens after you land on that page, like that you put your credentials into, what happens there is not part of OIDC or OAuth. right? When you click submit on that form, that's up to the identity provider to handle that authentication however they want to. So just so you know, like that part of it's not actually something that's in the spec. But MFA is a great security pattern for apps because it's an identification verification method that adds an extra layer of security on top of just, plain credentials. And they typically fall into 3 categories. And when I say they, I mean factors. So there's knowledge, something you know, right? A security question. And this is really not a great one, right? What's your mom's middle name? And that's why you see a lot of polls on like Facebook and other social networks these days where people are asking you like, where'd you grow up and what was your first car? Because they know those are like security questions. So don't answer those. And then possession is another factor, something you have. That can be your phone, which is usually pretty good, or a YubiKey. And then there's inherence, which is something you are, your biometrics, right? Your fingerprint, your face. And the funny thing about like MFA in general is SMS is actually pretty terrible, right? Because first of all, it can be compromised. We've heard many incidents of, someone calling up like T-Mobile and saying, I got a new phone, can you activate my SIM card for this number? And like for the longest time, I think a lot of the phone providers weren't like checking that. They were just doing it. So that's one way it can be compromised. So you might have to be targeted for that. But I have a story about my dad having some Bitcoin and Coinbase, and he lives up in Montana where I grew up, and he doesn't actually have a cell phone. So when they made him do 2-factor, they had to put in a number and he just put in his home number. But guess what? He couldn't get those Bitcoin for like a year because he couldn't get past the authentication. So that's where MFA can go wrong. And so, don't do that. And that was probably his fault, more than them. But I think it can happen to a lot of older folks just because they aren't used to all this stuff. They're happily ready to put in their Gmail username and password on any site, but the SMS can trip them up. So try not to use SMS. Use Google Authenticator or something like Okta Verify. Those are usually the best ones. Or a one-time password kind of thing to an email works. And 1Password actually works too. So I don't know if you know this, but 1Password has the ability to store, your MFA like tokens in there. So that's kind of nice. And speaking of 1Password, make sure when you're developing apps that your users can use password managers, right? And that's another benefit of redirecting to, an identity provider is you can, rely on them to do it. But man, it's such a pain in the ass when you can't actually copy and paste your password into a form. Like, who remembers passwords these days? I don't even know any of mine. They're all in 1Password. And so, there's different levels of multi-factor authentication, right? You start out with passwords, and then there's SMS, and then there's the one-time passwords, and then there's something like an app like Google Authenticator, and then there's even YubiKeys and Face ID and all that kind of stuff. So try to implement them more on the right side than the left side. And what's the latest thing that's going on here, Brian? There's what's it called?
Oh, passwordless. You're right. So we've kind of been talking about how you really don't want your apps touching your users' passwords. Come to find out, your users don't want to touch passwords either. So the other day I was playing a mobile game with my folks. So my folks live a few hours away, and I haven't seen them a lot. And with COVID and everything, and I play a lot of board games. And they are huge Ticket to Ride fans. So if you are not, if you don't know what Ticket to Ride is, it's one of the gateway drugs into the board game world. So go check it out. But anyway, so I called them up. We were going to play and video chat at the same time, and they both forgot passwords to their accounts. So I literally spent over an hour walking them through how to reset their accounts, right? They were playing on a tablet. They didn't have their email on their tablets. It was just a whole long drawn out process. They had to go to a different room, to a different computer. And, and I'm just, face bombing the whole time because I literally do this type of thing all day long. But yeah, it was painful. And I don't think we ended up playing the game afterwards. So it's a long way of saying passwords suck, right? So what do we do about it? So there's some alternatives now, right? So Okta sort of brands our passwordless features as FastPass, but you've probably used some of these techniques already. So there's magic links. So companies like Slack, Groups.io, and StreamYard do a really good job. You log in by clicking a button. They send you an email. You click on the link in your email, and in those cases they kind of rely on your email provider for the level of assurance. But there's also things like these 502 devices, like we started talking about, like Face ID and YubiKeys and Touch ID. All of these things sort of are going to help us remove the need for passwords going forward.
Yeah, that's a good point. And I really like our FastPass product. They just enabled it for us at Okta like 2 weeks ago. And so how it works is you'll download some sort of app and register, your computer. In my case, it might be a laptop or it might be my phone. And then you never have to enter a password again. So I haven't entered my Okta password in anything in like 2 weeks. And it even works in like private incognito windows. So that's pretty slick in that, I'm using my YubiKey to authenticate myself or my Face ID on my phone. And yeah, it's been a very pleasant experience. So if you can do it, do it. And so App Auth's security patterns, what we decide to do is rank them, right? Give them some reviews, give them some stars. So again, take everything with a grain of salt in this presentation, because these are our opinions. And you know what opinions are like? They're like assholes. Everyone has one. So HTTP basic, we give that 1, especially for apps, right? Because no one likes to see that little pop-up, and I don't know if all browsers allow you to paste in the password, but they probably do. Embedded auth, like it's the same thing. You're probably managing passwords in your app, and that's not great, even if they're encrypted, right? Because especially if they're encrypted, you're going to be slower to authenticate people. And that's actually a good thing, right? Bcrypt is a great pattern for really slowing things down and making it so people, might go away, just because, when there's password spraying your thing, it takes a while for them to authenticate. SAML, that's like, soap. It's outdated. It's old. JWT auth, you can use it, but a lot of the benefits that people use it for is like REST, or stateless authentication. And maybe that's not the best thing, especially if you're including identity or any information like that in those tokens. OpenID Connect, we recommend. We give it 4 stars because chances are there might be something better or it might be improving. We'll talk about that when we get into the OAuth section. MFA is great. The passwordless experience we've been using has been great. And so we give both of those 5 stars. So, Brian, do you have some thoughts on what's tired and what's wired in the App Auth area?
I do. I'm gonna try to speed things up. I think we're a little behind here, Matt. So just so briefly, we talked about apps handling passwords, right? And it always sounds like Matt and I are drumming up business. And obviously my paycheck would love for you to come spend money at Okta, but at the end of the day, I don't care, right? Really, we're just trying to make sure you don't build it yourself. I would rather have you use a different vendor or something than go, spend a whole bunch of time building, some buggy security solution. And we keep talking about sessions. So I did some poking around and come to find out all the big FAANG companies still use sessions. They have session cookies. So I'm pretty sure if Netflix can make session scale, it'll work for the vast majority of applications. What else is on here? So some of these things. So Matt's actually going to talk about the implicit flow. I think he touched on it a little earlier too. But basically, putting sensitive data in URLs is a big problem. The servlet spec still talks about sticking your session ID in URLs, and that's a big no-no in my opinion. It's sort of there because not all browsers or people are using cookies. But that leaks that information into URL, which maybe get logged, or they end up in your bookmarks or your browser history or whatever. So just avoid putting anything there at all.
All right, so now we'll move on to API auth security patterns, and these apply to like API developers as well as security people, because what we found is the security people seem to get involved when it's, living on your servers or your infrastructure, and the apps, living on other people's computers, they don't care as much about. So, these are backend developers, you're a Java developer, maybe a Node or Python or .NET even, and, SPAs, you think that SPAs are the worst thing that's ever happened to web development and long for the days of Spring MVC and time leaf. And you might even like JSF. So in this section, we'll talk about patterns for securely connecting your clients to your APIs, as well as how APIs authenticate to each other. And so one of the first ones I want to touch on is HTTP basic, because it does apply to, the backends as well. So this is some YAML from JHipster. When you generate a microservices project with JHipster and you connect to, Spring Cloud Config, you'll see here it's got a URI with the registry password there, right, in plain text. So it is still a pattern that's used, out there, and so it can be useful, but we think there's better ways. So Brian, what do you think of tokens?
All right, so I'm trying to respond to chat. I can't do two things at once. I'm sorry for everyone talking. We will definitely try to answer your questions in the Q&A. I can only focus on one thing at a time here. All right, so Matt lives in Colorado, and that's beautiful. Don't get me wrong. I live in New Hampshire, which a lot of people think of the natural beauty and everything. People in a month, people are literally going to drive in the state to literally stare at our trees. It's going to be great. Leaf peeping. So if you're not aware, the fall time's coming in the northeast portion of the states. It's beautiful, but I kid. So really, though, the claim to fame in New Hampshire is that we have the world's largest arcade. So if you didn't know this, it's a Guinness Book thing. It's called FunSpot. It's great. They have a whole floor of classic arcade games. Anyway, so I like to use this as an example of how tokens can work. So everybody's been to an arcade. I show up and I need to provide my credentials, right? So FunSpot really only cares about one thing, right? It's my $20. So I give them my $20 for credentials. They don't even care. They just accept it. And they hand me back a bunch of tokens, right? These are physical coins. Sometimes they look like this. Sometimes they have something else on them, but they're almost quarters. And then I take that and I run upstairs and I go play the classic arcade games. My favorite is Arkanoid. If you don't know what Arkanoid is, go play it. I'm sure you can find it online somewhere. But just like our APIs, there are problems with this. These are basically static tokens. So what if I leave my tokens somewhere? Someone can go steal a couple, right? They grab a couple out of this cup or whatever, or they just push me over and take my tokens. I don't know. But there's no way to rotate these tokens. If FunSpot wants to change the type of tokens they use, they literally have to go retool everything in the building to change out the infrastructure. It's problematic, right? So tokens are great, but they really need to be used as part of an overall system like OAuth. Hey, Matt, do you know anything about OAuth?
It's a good thing to point out, though, that tokens actually will work just fine if you're like a small app or a small company, right? Like some of these things are more for, big major sites. So OAuth is super complicated, and these are all the specs that are in OAuth. So if you'll notice, this is from our colleague Aaron Parecki. There's a whole shit ton of them in there. So the story that I like to tell is when I started Stormpath, I wrote a module for JHipster that integrated Stormpath for authentication, and Stormpath was unique in that once you integrated it, it would talk to the API and you didn't really have to do much work yourself. And then when Okta acquired us, they had OAuth 2. So we were like, we should refactor JHipster because it has an OAuth 2 component. And I'll just refactor that to work with Okta or see how I can do it. So what I discovered when I jumped into JHipster's code base was, first of all, they had their own OAuth server, authorization server, powered by Spring Boot and Spring Security. So I don't know if you remember UAA, that was a product for a while. But that was weird because we're using OAuth, but it's storing all the credentials in our JHipster apps database. So that's kind of weird. And then I found that the client ID and the client secret were in plain text in JavaScript, right? And so that was like, I've just learned a bit about OAuth, but I know client secrets and SPAs are a bad idea. So, that was kind of crazy. And then, when OAuth 2 was published in 2012, the iPhone was brand new. The latest browsers from Microsoft was Internet Explorer 9, and single-page apps were called Ajax apps. And CORS was not even a thing. So things have really changed a lot since then. And it originally had, 4 different grant types: authorization code, implicit, password, and client credentials. And over the years, it's had things added and removed, and now it looks more like this. So the security BCP there is the security best current practice. And so implicit and password, implicit was there so you could, get an ID token and an access token in the browser without CORS. Now we do it with CORS. And the other one, passwords, was more for like Windows 3.1 because they couldn't pop a browser. So they used, username and password as a grant type. And what I've seen is people will implement OAuth and they'll use the password grant type. And it's like, man, that's the whole point of not using OAuth, right? Is trying to protect people and not have them type in their passwords. So, if you look closely, one of the things that's come as a recommendation in OAuth 2.1 is, OAuth for authorization code plus Pixie, and client credentials and device grant. Those are the only grants. So you can learn more about auth.net/2.1 there. And let's talk a bit about client credentials. So client credentials is basically a way of doing service-to-service communication without any user interacting. So it basically mitigates the risk of having the client, request the access token from an authorization server, and it just basically, works pretty well. But again, if you're using OAuth and you're like using Keycloak and you're managing everything yourself, or using even Spring's new authorization server and managing passwords yourself, then, well, you don't have anyone to blame if anything goes wrong. So, what we recommend is, look into OAuth and, try it yourself. Keycloak authorization server, right, from Spring work great locally, but, try to code your app so you can switch to a different IDP if you need to. And then what about gateways, Brian?
So API gateways are one of my favorite patterns of this talk here. So there's actually a couple talks. I know there was one yesterday, and I think there was one or two other talks that touched on API gateways, specifically Spring Cloud Gateway. So if you want to learn more, definitely go follow up on those too. But I think it works really well for new apps. You can take advantage of all the new power. But it's actually really great for legacy apps too, and a lot of us sort of remember the days of setting up load balancers and reverse proxies, and you can kind of think of it working the same way. You have some sort of client, that client makes a request to the API gateway. The API gateway can handle all the complexities and going through that maze of OAuth that Matt just showed, and deal all the song and dance, right? So if it has to do a redirect for a user in a browser, it can do that. If it's a REST client, it can deal with rotating access tokens and everything. And then the communication between the gateway and your actual service, in my case, dogs, cats, or fish, is actually just client to client, right? So machine to machine. It's actually a very simplistic way to deal with authentication. So it simplifies your application and moves all that complexity into one piece, and you can load balance that as needed as well too. And it's not just Spring Cloud Security, like that's a great product too. But there are some commercial offerings, like from Kong, Nginx Plus. I don't know what their Plus is, but I know they offer an API gateway now, and there's a few other vendors in the space too. So definitely, I would recommend checking it out.
And you said Spring Cloud Security. I think you meant Spring Cloud Gateway there, right?
I wrote gateway on the slide, so that's gonna help out.
All right. So another thing that I've learned, in my experience at Okta and talking to APIs is use API SDKs if they're provided by the API vendor or the app, or maybe even write your own. And so I use this this photo from SDK Man because I just like the logo, right? So API SDKs aren't really related to SDK Man, but maybe. And if you're not using SDK Man to manage your JVMs, look into that because it works really well. But you can talk directly to an API, using REST or even SOAP or Postman or whatever, but it's often a lot easier with SDK. So instead of you writing a REST template or a web client and 20 lines of code, you can just write 3, embedding that client into your app. And so definitely recommend that. But, as a caveat, sometimes talking to the API, you get things faster. Like the API gets updated, every couple of days or every day. And then the SDKs are released, every week or two or every month. So, just be aware of that talking directly to the API, you'll always get the latest and greatest. SDKs might lag a bit as people add features to them. So the other thing I wanted to mention as a pattern was encrypting and rotating secrets. Secrets might be an API key, a client secret, or credentials for basic authentication. So the number one rule for secrets is don't check them into source control. First step is, adding them as environment variables, but that's only the beginning. You should, definitely encrypt your secrets and store them in some sort of vault. So there is ways to encrypt them and store them in things like GitHub, but it's better to use like HashiCorp Vault, Azure Key Vault, Amazon's like KMS, or even Google's Secret Manager. And then what about our last pattern here, Brian?
Yeah, so we have RBAC and ACL. So RBAC is role-based access control, and ACL is access control list. There's some subtle differences between the two. With the access control list, the thing you're protecting kind of has a list of what can access it. And then RBAC is sort of how my brain naturally thinks about things, and what I typically recommend is basically you stick your users in a groups. In my case, whatever, I have admin, user, and help desk. Those groups are actually basically associated with roles, right? The roles in my case are the names. And then I like to think about things with privileges or permissions. So I associate a set of permissions with those roles. And then my application really only can focus on the privileges. So it doesn't really care how my business logic needs to work and structure. I'm free to change that, but my application can sort of just focus on these permissions. And in the Spring security world, these privileges end up mapping to authorities. You may have seen like a has authority using the annotations or some of the DSL. But I would absolutely recommend checking out this, especially in Spring security.
All right, so now we have our ratings, right, for API Auth security patterns. HTTP basic, we give it 2 because it's still used, around a lot of things like Spring Cloud Config by default. Tokens, you're getting a little better, especially if you're doing small apps, like just associating a user with the token or having API tokens to talk to your whole thing is just fine, but still not the best. OAuth 2.1, highly recommend that. API Gateway as well. Spring Cloud Gateway has been real nice. Really enjoy using that. API SDKs, we only gave it 4 stars because it can lag behind the API. Encrypting your secrets, of course, do that 5 stars. And RBAC and ACLs, great thing to do. And it's funny when you talk about HTTP basic, I did want to mention just, tokens are faster than HTTP basic. I mentioned that earlier because they don't have to calculate or parse the password. And bcrypt is like slow on purpose. So Codify, you might remember him from Drop Wizard. He has this blog post that's like about how to safely store a password. And he just recommends use bcrypt if you are storing passwords. And that's because a modern server can calculate the MD5 hash of about 330 millibytes per second or megabytes. So if your users have a password that are lowercase, alphanumeric, and 6 characters long, you can try every single possible password of that size in around 40 seconds. Decrypt with a work factor of 12 will take 12 years instead of 40 seconds. So, your hashing algorithm is important, and just use bcrypt. And so Tired and Wired.
Yeah. So again, we gotta move things along here. But yeah, so build it yourself. It's worth repeating that. Don't be building this stuff yourself. Right. Use existing libraries. Static API tokens. As Matt mentioned, sometimes you have use cases that are great. But if you can use something like a short-lived access token, an OAuth access token, you might be better off, right? If one of these tokens leak, the time frame that token is available and valid is minimal, and you can shorten the time frame as well too. And Matt also touched on cores. So if you're building front ends and need to talk to back ends, make sure cores is configured correctly. Don't just use wildcards, right? You want to always practice the least privilege principle. So restrict access to the bare minimum needed, and then only expand that when the need arises.
All right, it's a good mention of cores and wildcards because some IDPs allow that, and that's actually one of the things they're trying to fix in OAuth 2.1 is make it so it's strictly a full URL without any wildcards in there. And so Infra Auth patterns is our next thing. And, these typically don't concern app or API developers because they're not responsible for deploying, updating, or monitoring your code. That can be different in your environment if you're a startup. So, keep that in mind. And caveat here is that Brian and I have the most experience with app security and API security, and we've been sysadmins in our own home and while working at startups, but we're not by no means like DevOps experts here. So the first pattern, Brian, is one of my favorites.
Yeah. So, again, I'm going to speed through this a little bit because we have like 6 minutes left. But if you're not already using Linux, you probably want to. It's literally the foundation of everything modern. Kubernetes, everything we're doing nowadays is Linux. When I started out, it was pretty common to build Java web apps on Windows, and it's always painful. Even a few years ago, I worked at a big Fortune 500, and we were deploying Java apps on Windows, and it was racks of Windows machines. The automation was slow. it was always kind of a second-class citizen. We'd use open source tools, and the Windows support always dragged behind because, even as app developers, right, and library developers, Linux is sort of the first thing we build on, right? Your CI systems, most of those sort of, especially the public ones, sort of prefer Linux first. So, you need to make sure you can automate and move fast when you're building stuff.
Yeah, and if you're using Linux, you're probably familiar with SSH. So, secure shell, use keys. The problem is it can be tough to clean up those keys or audit the keys. So, make that a part of your regular, process to look on your servers and make sure that employees' keys aren't there that are no longer with your company. And make sure and audit, your SSH usage because, you want to know who's logging into your servers.
Yeah, so this is one of my favorite things about the web nowadays. So certificates used to be a real pain in the ass, and nowadays it's a lot easier. We still have to deal with them, right? So we went from basically that not secure to Let's Encrypt makes it easy. So if you're not already familiar with Let's Encrypt or check it out, definitely go do so. One of the easiest ways to go play around with it, go deploy something on Heroku or something with and set up a custom domain. You can get the whole thing up and running in like 5 minutes. One of the best things that's happened to the web in recent years, I think, is limiting the time frame that certs have been available, and sort of it forces us to automate, which will make us make our application deployments much more secure.
And then we also have SSO for servers, right? This might be Active Directory if you're on a Windows network. It might be PAM if you're on Linux, right? The pluggable authentication modules. And then vaulting was like an old way of doing it with Linux where you'd actually lock stuff down and have a one-time password and stuff. And we even have an Okta Advanced Server Access product that will make it so you can use Okta to control your SSH and do, deprovisioning of users that have left the company or whatnot. And so Active Directory, try not to use that because you're using Linux, right?
Right. So, at one point, we got really good at patching servers, and then we moved to containers. And then somewhere along the way, we didn't realize that they're same bits, just in different places, and we still need to treat them the same way. So make sure you're scanning what's in your containers. Don't just YOLO it, grab a container that you don't know what's in it, and then use that. Make sure you're scanning things. Make sure you know what's in production versus what's in your code base. So, if things change in your code base, how long does it take you to get it out to production if some vulnerability is found? So scan them. There's a bunch of options. There's Sneak. So Docker Scan is powered by Sneak. There's Claire. There's all kinds of options. Even Dependabot now can help you out with your Docker images.
And I think it's important, right? We're talking about security at all layers. So maybe this isn't really Auth, right? This is more like the HTTPS realm. But, know your cloud and cluster security when it comes to like Kubernetes, right? And if you're buying a box of DevOps, that might not always be good enough. So the 4 C's of cloud native security, I think, are important: cloud, clusters, containers, and code. So each layer of the cloud native security model builds upon the next outermost layer. So the code layer benefits from the strong base, the cloud, the cluster, and container, right? So you cannot safeguard against poor security standards in the base layers by addressing security at the code level. So, if you go to this link at the bottom there, there's a link to all the major cloud providers' security docs when you're using Kubernetes. So we certainly recommend that. And then some tips for Kubernetes is only expose what needs to be exposed. Scan and update your YAML. This podcast from InfoQ is great, from Alex Metashentsev on Argo CD, Argo rollouts, and continuous delivery with Kubernetes. He's from Intuit, and he talks about how they have, thousands of microservices, or maybe just hundreds, but they go through and scan them and update them and, give them new API versions and all that kind of things if they need to do it. And then another tool to check out is Kubescape. And it's the first tool for testing if Kubernetes is deployed securely as defined in Kubernetes hardening guide from NSA and CISA. And now, since we have a minute and a half, I'll speed things up. So encrypt your Kubernetes secrets. Don't just use plain Kubernetes secrets. Use kubectl and sealed secrets from Bitnami. And then automation is key, right? So make sure and do that. And then on to the Auth security patterns: Linux 5 stars, SSH with keys 3, certificates 4. And we gave all the rest 5 stars because it's like, a restaurant during COVID. You didn't want to give them 4 stars. You didn't want to make them look bad. You just wanted to recommend them.
All right, yeah. So quickly, some wired and tired. Don't use large images. Keep them small. You can use build packs. Some best practices, right? Don't stick secrets in images. We talked about this, but that's also, if you're building VMs or WAR files or jars or whatever, keep your secrets out. You can use something like HashiCorp Vault, or Matt mentioned a bunch of other options before. And shared credentials. Stop it. Just stop. You need to limit access. If someone leaves a company, you can't really revoke a shared secret.
All right, so 30 seconds for action. I'll just breeze through these if you don't mind, Brian.
Go for it.
Codify. Use secure by design. If you're not familiar with it, read the book. Use Spring Boot and Spring Security. They have a lot of these patterns in there. They allow you to do CSRF. They allow you to protect things easily. JHipster does a lot of that on the back end with Spring Boot and also on the front end. Scan with security headers to see if you have security headers. Pen testers, don't use implicit flow, and test for vulnerabilities. And OWASP is there, but it hasn't really changed. Check us out online. Thank you, and may the Auth be with you.
Thanks so much, Brian, Matt. That was just an unprecedented and comprehensive coverage of the entire security landscape with regard to running applications in a cloud-native way. And I learned so much about security tokens, encryption, as well as some of the tools that are available for our ops friends managing platform. So as always, folks, if you're joining us, this channel, the Slack channel, it's called Session Auth Security Patterns for Apps, APIs, and Infra. Get in there. There's a bunch of incredible discussion going on, and you expect that Matt and Brian will be jumping on with the Q&A in the Zoom link that's available in that channel. So get over there. Cheers.